A distribution center for a leading manufacturer of eyewear could only process 70 to 90% of all daily orders on straight time. The company needed to identify and correct the bottleneck causing the delays while keeping costs to a minimum. The layout of the distribution facility consisted of bulk pick areas, carousels, and flow racks, as well as an automatic dispensing system. This layout was inefficient in meeting the total demand of orders, and as a result, they had to run overtime and weekends to meet the demand. Managers also tried to increase staff in different areas of the facility, but were unable to meet their requirements or affect the system throughput. ProModel was engaged to develop a simulation solution in order to help them determine the root cause of their inability to meet customer demand, as well as the necessary implementation needed to increase throughput at minimal or no cost increase. The ProModel solution consisted of 3 separate models. The first model included a CAD layout of the facility and data provided from the warehouse management system that depicted the volume for each order type. The first runs of the model determined that the conveyor system was the bottleneck, limiting the total throughput. Based on this data, managers decided to rearrange the tote introduction areas on the conveyor system and create 2 new tote areas, one at the flow rack and one upstream of the itomatic area. This was tested in the simulation model, and the predicted increase in capacity was only 10%. The model also confirmed a new bottleneck located in the print pack area. It was decided that breaking the print pack area into 2 separate operations would be the best approach to solving the problem. This resulted in a printing order verification area and a packing area. To help determine the best design and throughput capability for the printing stations, a second model was built comparing a single printer station with a double printing station. The results showed a 100% increase in throughput with the double printer station, and the utilization of that operator would be 92% versus a maximum of 46% in the single printer option. The double printer option was selected due to the increase it created in throughput and operator utilization, as well as no additional equipment costs. A third and final model was developed to redesign the facility to allow space for the new printer stations. After running a number of scheduling scenarios, the design was refined to meet future projected demand requirements with a 30% buffer capacity. After implementation, actual operation results were within 5% of the model's predictions, allowing them to meet 100% of their current order requirements on straight time with protective capacity for increased future demand. Excessive overtime labor costs were also significantly reduced. Currently, the model is continuing to be used by the company to help determine the staffing requirements and shift schedules for each area of the distribution center.